One of the main goals of the INTAROS project is to enhance in situ observations in the Arctic regions. It should be done by making use of existing reference sites and observatories, adding new key variables, and implementing new technologies. INTAROS in situ observations cover 3 regional sites and 2 distributed observatories. Marine and ice observations in coastal Greenland include measurements of ocean variables by moorings and also from ships, and a wide range of observations on Greenland ice sheet. 2 new moorings were deployed in Young Sound for physical and biological parameters. Additional measurements of ocean acidification are collected from vessels and small boats at sections around Greenland. Also in Young Sound, the passive acoustics is used for long-term monitoring of physical and biological environment. On Greenland ice sheet, INTAROS contributes to the PROMISE network. For example, 5 snow foxes were deployed for measuring the snow water equivalent at 4 places on Greenland. Multi-year measurements of ice melt are improved by new additional sensors, a device for precise positioning, and a tilt and azimuth sensor. INTAROS moor terrain north of Svalbard covers the section from the shelf break to deep ocean and measures a wide range of key physical, biogeochemical, and biological variables year-round. Pilot experiment was followed by 2 field deployments with 7 and 4 multidisciplinary moorings. Additional measurements were collected during the mooring service cruises. 7 moorings deployed in 2018 carried instruments for measuring ocean temperature, salinity, oxygen, ocean currents, and additionally sea ice drift and draft. Examples of year-round data include profiles of ocean currents and point and profile measurements of temperature and salinity that were collected during 1-year deployment. A multidisciplinary mooring was deployed for collecting biogeochemical and biological observations in the key location, in the Atlantic water inflow to the Arctic Ocean. Also, an array of ocean bottom seismometers was deployed close to the seismically active mid-Atlantic ridge and near Greenland. In Fram Strait and Svalbard fjords, new observations were focused on autonomous measurements of ocean acidification and on acoustic monitoring. A novel autonomous system called ARC-FOSSE was developed to assess the effects of changing ocean chemistry, in particular ocean acidification, on benthic organisms. After extensive testing, the Arctic-FOSSE system was deployed in Fram Strait in 2018 for 1-year deployment period. This challenging deployment of a very complex system was done in the long-term Hausgarten Observatory from the research vessel Maria Merian. In summer 2019, sediments and also inhabiting organisms in the Arc-FOSSE area were sampled with the ROV. A continuous time series of carbonate chemistry are collected in Kongsfjorden at the AVIPEF Observatory, and these time series are available online in real time. The noise generated by winds, waves, ice, and ship traffic, and also sounds of benthic fauna, are monitored with passive acoustics also in Kongsfjorden. Distributed systems for ocean and sea ice include ice-tethered platforms and buoys, ferry box instrumentation, glider endurance lines, bioargo floats, and quadrocopter measurements over sea ice. YAO's ice-tethered platform was deployed for INTAROS from Oden in 2018, but these measurements were shortly interrupted by a polar bear intervention. Additional deployments of ice-tethered platform and also Simba buoys took place during the Catex cruise that reached the North Pole in 2019. A deep ocean mooring was deployed for 1 year in the central Nansen basin to complement measurements with drifting platforms. An array of Simba buoys for measuring sea ice thickness and snow ice ocean temperature was deployed during different cruises in 2019 and 2018. Examples of SIMBA data show changes of temperature at the air, snow, ice, ocean interface, snow depths, and sea ice thickness. Novel sensors were developed for the Fairybox measurements from MS Norbjorn that are collected along the route between Tromsø and Longyearbyen. New drone-based albedo measurements were planned for the Mosaic campaign, but a part of them could not be obtained due to COVID-19 limitations. High-resolution measurements of physical parameters were also collected by gliders along the endurance lines west and north of Svalbard. Distributed systems for atmosphere and land covered a wide range of observations collected at land stations, by airplanes, and from icebreakers in the Arctic. For example, an automated flask sampling system was developed for greenhouse gases measurements in Greenland and Siberia. Novel sensors for atmospheric and soil measurements were implemented in the Barrow Observing Cluster. A new de-icing system was built for sonic anemometers that are used on edicovariance towers. High-resolution soil temperature profiles have been collected for continuous measurements of water table and thawing depths. Novel spectral albedo and surface measurements were implemented at the Sodankila Arctic Space Center Observatory. INTAROS also contributed to development of semi-autonomous system for atmospheric observations from ships of opportunity. The system was tested for surface flux measurements during the icebreaker Odin expedition in the Central Arctic in 2018. Only the selected examples of INTAROS in situ measurements were shown by the poster. For more information, please visit the INTAROS website and also the INTAROS data catalog. Thank you.